I'd like to begin by reciting a haiku that I wrote about my love of the ice landscape and its fragility in our environment. Metamorphosis, a snowflake and ice crystal, each alone unique. Illumination, kaleidoscope-splitting light, refract and reflect. Ultraviolet, infrared radiating, absorb or disperse. Open corridor, individuals combine, and so on until endless white vista, icebergs dancing in oceans, snow embraces trees, glaciers rise and fall, fragile moments transforming, water messages. My approach is to use art as a platform to discuss how the environment shapes the Earth's landscape. I find that ice and snow act as a great palette for me to capture environmental effects on the landscape because they quickly change with a change in the environment. I began photographing landscape in 1998 by experimenting with high-speed black and white infrared film. This film was used to take unusual photographs of landscape where the foliage would be white and the sky black. I wondered, if I photographed only a small segment of snow and ice, what would infrared light look like? I set out to experiment with my Leica loaded with this film. On a warm, sunny morning, I traveled in a snowmobile through Independence Pass in Aspen, Colorado. Both infrared and ultraviolet light waves are beyond our visible spectrum, so I had no idea how the image would appear. But when I arrived back in New York and developed this film, each image was surreal. Even though this film has been discontinued since 2009, I have a large stock of it in my freezer, and I continue to use infrared film in order to see beyond our visible spectrum. This photograph is from my first series, Distillations. It illustrates the way infrared light records infrared light waves. The areas in this image that are absorbing infrared radiation, parts are black. Believe it or not, this is a snowdrift. I now wanted to explore ultraviolet radiation, but this is a little more problematic since ultraviolet film does not exist. In order for me to photograph ultraviolet light, I would need to go to places in the world that had an abundance of ultraviolet light. In 2012, as JD said, I was granted a National Science Foundation Artists and Writers Grant in order to photograph Antarctica during its austral spring. Antarctica has an ozone hole, which allows for more ultraviolet light to reach its landscape. This is a photograph of the pressure ridges outside of Scott Base, which is the New Zealand Antarctic Research Center. Ice crystals on the sea, ice, act as prisms, where ultraviolet light is reflected and absorbed into different colors of the ultraviolet light spectrum. Exploring the effects of infrared and ultraviolet radiation led me to research the causes of global warming on the Earth's landscape. I'd read scientific journals, talked to different scientists, read data, and saw satellite images of the Arctic. But there's no substitute for physically experiencing the effects of global warming firsthand. I knew that the Arctic was and is melting faster than any other place on Earth. I wanted to document this melt before the ice in the Arctic disappeared. My most recent series, The Arctic Melt, Images of a Disappearing Landscape, is the result of visually documenting the melt that is occurring in the Arctic. I'd like to show you a short video that I produced on the Arctic melt. Sound? 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 wait a minute. I'd like to go back, because no way to start it again. Okay. During the summers of 2015 and 16, I traveled throughout the Arctic in order to experience and document this melt. This is my 5th trip to the Arctic since 2001. Each trip contributed to my witnessing the melt that was occurring in the Arctic. The melting of the ice in the Arctic will be the cause of ocean rise. Ocean rise will be caused by 3 factors: the melting of the mountain glaciers, the thermal expansion of the ocean, and the melting of the Greenland ice sheet. And as you can see this year, we're experiencing the melting of the Antarctic ice sheet. In order to capture all 3 of these factors, I traveled to Svalbard, Norway, through the Arctic Ocean to the North Pole, and to the Greenland ice sheet. Svalbard, Norway is an archipelago located in the middle of the Arctic Ocean, halfway between northern Norway and the North Pole. Its 23,000 square miles of pristine glaciers would be a perfect place for me to photograph in order to see if actually the melt was happening in this northernmost area. Flying over Svalbard's glaciers is prohibited. With difficulty, I was able to secure a permit and successfully rent one of the only helicopters to fly over the area. In this image, ancient Devonian red sandstone washes down the sides of the glacier, forming red rivers in its valleys. I couldn't help but think, are these glaciers leading to death? The sea ice around Svalbard had broken into small pieces, and I was told that it was melting earlier every year. Turquoise blue meltwater ponds were strewn through the glacier. This was evidence that the melt was occurring even in this northernmost mountain glacier. An additional contributor to ocean rise will be the thermal expansion of the ocean. With the increase in carbon dioxide and methane in our greenhouse gases, our atmosphere is getting warmer. causing our oceans to become warmer, which will result in its expansion. I wanted to experience the melt of the sea ice firsthand, so in order to do this, I would have to travel in a Russian nuclear-powered icebreaker. This would be the only way I could reach the North Pole. So in June of 2015, I traveled from Murmansk, Russia, through the Arctic Ocean to the North Pole. The amount of open water was surprising. When I began my journey, I thought that I would see several polar bears, but during my 2-week trip, I only saw 3 adults and 3 cubs. The sporadic snow patties were occluded the difficulty that the polar bears were having in living and navigating in the Arctic waters. In the past, the sea ice was too thick to reach the North Pole in June. But now, because of global warming, we were the 3rd earliest surface vessel to ever reach the North Pole. In fact, the ice was so thin that we could not disembark. We had to search for 3 hours in the area to find a piece of ice thick enough for us to get off the ship. Even though we were at the North Pole, the temperature was a balmy 32 degrees Fahrenheit. It is estimated that the Arctic Ocean will be ice-free by 2040. What are the repercussions of having an ice-free Arctic Ocean? The Earth needs a certain amount of ice to reflect sunlight back into outer space. Without this ice, more sunlight will be absorbed into our atmosphere and oceans, thus increasing global warming. In 2016, I was invited to watch ice core drilling in the Greenland ice sheet. I learned that through analyzing past ice cores, scientists can determine what the future atmosphere of the planet will look like. The last time our carbon dioxide was the level that it is today was 3 million years ago, when humans did not exist. The temperature was 8 degrees warmer, the ocean was 20 feet higher, and tropical trees grew in the Arctic. This is a pretty frightening prediction. The third factor that is going to contribute to ocean rise is the melting of the Greenland ice sheet. My last trip to Ilulissat, Greenland was in July of 2007. Seeing the difference in this landscape was shocking. In 2007, the glacier surrounding Disco Bay calved colossal snow-covered icebergs. Now in 2016, the glacier were calving at such a rapid rate that the entire inlet was filled with tiny icebergs in a constant state of melt. Waterfalls fell from the top of icebergs, rivulets rained from their interiors, and icebergs broke apart and fell into the sea daily. The Greenland ice sheet in 2007 was a blanket of fluffy snow. Now in 2016, the ice sheet in the same location consisted of rough peaks of snow and silt that emerged from meltwater ponds and lakes. These ponds empty into moulins, which eventually drain into the Arctic water surrounding Greenland. The temperature in Ilulissat on July 16, 2007 was 30 degrees Fahrenheit. Just 9 years later, on the same date, the temperature was 65 degrees Fahrenheit. My exploration and documentation proved that the Arctic is melting, and that the situation is significantly worse than I had expected. For 800,000 years before 1749, which was the beginning of the industrial age, the carbon dioxide level had not been above 280 parts per million. Today, the carbon dioxide level is 408 parts per million and steadily rising. This increase, along with increase of methane in our greenhouse gases, is causing the warming of our atmosphere, which will result in ocean rise. Millions of people will be displaced due to soil erosion, causing economic and political upheaval. There is no substitute for visually seeing the effect of climate change on our Earth. My photograph acts as a platform for the public to see a landscape that is quickly being affected by the reality of climate change. We need to treat climate change and global warming as a serious threat and find solutions that will slow the rapid increase of global warming before it's too late.
Thank you, Diane.